Low voltage and high voltage circuit flow, step-by-step wiring flow. Welcome to class Low Voltage and High Voltage Circuit Flow, a complete step-by-step guide to how power flows through an air conditioning system. This is one of the most important classes in the course. If you understand how power enters, transforms, and flows, you'll be able to wire and troubleshoot any residential system like a pro. Let's begin. High voltage, 240 volts. Let's start with the high voltage, which powers the air handler and condenser. Power begins at the main electrical panel inside the home. From there, two dedicated double-pole breakers send out 240 volts, one circuit for the air handler and another circuit for the condenser. Each circuit typically uses two black wires for hot lines and one green wire for ground. However, sometimes one hot wire is black and the other is red. Inside the air handler, power enters through the disconnect and goes to the internal breaker. From there, it connects to high-voltage components like the blower motor, the electric heat strips if present, the transformer, which steps down the voltage to 24 volts. Important, always verify the wire thickness matches the amp rating on the equipment label. Incorrect wire size can cause overheating and fire risk. We'll leave a wire gauge and ampacity chart in the course PDF. When voltage passes through the contactor, in the condenser, 240 volts enters through the disconnect and goes to the contactor. After the contactor closes, power is sent to the compressor and the condenser fan motor. At this point, wire colors often change. Inside the condenser, you may see black and red going to the compressor, even if both wires were black before the contactor. Same for the air handler. After passing the breaker, you might see red and black for blower and heat strip connections. But don't assume, always verify with a multimeter. Low voltage, 24 volts AC. Now let's talk about low voltage, the 24-volt control circuit. Inside the air handler, the transformer receives 240 volts from the internal breaker. It has two high-voltage input wires, usually black and white, and two low-voltage output wires, typically red or orange, 24 volts hot, blue or brown, 24 volts common. Warning, if the transformer fails, the entire low-voltage system dies. Right after the transformer output, the 24-volt hot wire passes through. A 3-amp fuse on the control board, if present. Safety devices like the float switch and drain line shut off. Then it connects to the R terminal on the thermostat. These safety switches are wired in series. That means if any one opens, the 24-volt power is interrupted and the whole system shuts down, including the thermostat display. The common wire C also runs from the transformer to the thermostat and to the outdoor condenser coil, completing the control circuit. Example, 24 volts flow sequence. 240 volts comes into the air handler, feeds the transformer. Transformer outputs 24 volts, AC 24 volts hot, passes through. 3-amp fuse, float switch in the drain pan. Secondary safety switch, e.g. AG84 at drain line. Then connects to R terminal on the thermostat. Thermostat sends signal to Y and G. Y energizes contactor and condenser. G energizes blower motor relay, and all of that happens through thin, low-voltage control wires. What can interrupt the 24-volt circuit? Here are the most common issues. Blown fuse on control board, tripped float switch due to clogged drain, faulty transformer, shorted contactor coil, low-voltage wire touching metal casing causes a ground short. Example, if your 24-volt fuse keeps burning out, check the contactor, the float switch, and the thermostat wiring for shorts. Why a burned fuse equals safety. If the 24-volt wire that passes through all these components ever touches metal, it creates a short circuit. That's why the fuse is there, to burn safely, instead of damaging expensive components. If the system isn't turning on and the thermostat is blank, this is the first thing you should check. How about thermostat control wires? Let's review them again quickly. R, red, 24 volts power. C, blue or black. Common, yellow, cooling signal. G, green, blower W, white. Heat O or B, orange or blue, reversing valve for heat pump. Remember, if the thermostat has batteries, the C wire is optional, but smart thermostats always need C, and the O or B wire energizes the reversing valve. O equals cooling mode, B equals heating mode. Never use O and B together. Your system is either one or the other. Wrap up. You've now learned the complete flow of 240 volts high voltage, how 24 volts low voltage is created and routed, where safety devices are placed, how thermostats control logic through terminals, What causes system shutdowns in the control circuit? You are now ready to trace and troubleshoot both power and control sides of a residential system.